So something else that's really nice that you can add to your scatter plots is the actual correlation, right? So we can get an individual correlation. You could show it like after a graph in Colab. And so like we've defined here what Y and X are. And, the correlation would actually be a little bit different because this is a sample, right? It's not the full data set. So how do you get that? It's an effect like column, which in this case we can do Y dot core X, right? X dot core Y is the same thing. So correlation is a method on a pandas series, which is cool. And we can show it by putting it inside of an F string, right? So we're going to print out, that would just be the number. But what's nice is to say what that number is. How does anybody know if you don't tell them? So if we put it all inside of an F string, then we could say correlation. And in this case, because it's coming after a plot, it would be obvious what it actually is. So you can just put it in squiggly brackets. Okay. Fair warning, inside of an F string, I tried it before with the using this, like the actual df, etc., and it didn't actually work right. I think because it got confused with too many quotation marks. And so sometimes it can be simpler to use variables, even if you don't have them already. Okay, so let's run it again. And you can see now what we have is really nice here is a correlation at the bottom. Okay, that is really cool. And additionally, I should let you know if you run this multiple times, like you see how it's 0.700. So if we run it again, we get something a little different. And why? What's going on here? Well, it's because each time we're running this coding cell, we're changing the sample. And I think that's you could move it, but I think it's totally fine and cool to get something a little different each time because it does give you a better sense of how the statistics are actually working, right? If you're taking a sample that's a quarter of your data set, you're going to get something a little different if it's a different random 4,000 numbers each time, but they should always be very close, right? They shouldn't be like completely different. You can see these three are all within 0.01 of each other.